just a cosy here. Here we have a definite integral. It's the integral of the cosine of this expression, and the limits are 0 up to pi upon 9. So the integral from 0 to pi upon 9 of the cosine, not of x, but of 3x minus pi upon 6. Now in the exam, you get given a table of standard integrals, and here we have cosine of ax, and the integral of that is 1 over a sine ax plus c. Now that works in the case of 3x minus pi upon 6, and it would mean that we get sine, not ax, but ax and a constant subtracted, but this divide by a, which is the coefficient of x, still holds. We divide by the coefficient of x. So long as there's a linear expression, some number times x plus or minus another number, then this procedure works. We integrate cosine to get sine as normal. Because there's a 3 lots of x, we divide by that 3. Now the reason that we do that is, if we check by differentiating back, remember differentiation is the opposite of integration. If we try and differentiate sine 3x minus pi upon 6, if that was y equals that, and we try and differentiate that, we would get the cosine of that expression, but the chain rule tells us we'd have to differentiate 3x minus pi upon 6, which is 3. So we'd get a factor of 3 appearing there. So if we try to go back, the integral of cos 3x minus pi upon 6 times 3 would give us that. So that's not what we've got there. We have a divide by 3 to cancel this times 3 that appears there. So let's just double check that. It's getting slightly more complicated now. But if we differentiate that, then we'll get the cosine 3x minus pi upon 6 times 3 from the chain rule, and there was a 3 sitting there which cancels that, and so we'll get our cos 3x minus pi upon 6. So we need this divide by 3 to cancel out that factor that's actually coming from the chain rule in reverse, if you like. Anyway, forget about all that. Just follow the rules. Integrate cosine, you get sine because it's not x. Divide by the coefficient of x. So there we are. Now, what do we do with these limits? Well, we put x equals pi upon 9 in that expression, and then we subtract, and we put x equals 0 in that expression. So pi upon 9 in there, we've got sine 3 lots of pi upon 9. That's pi upon 3 when our cancelling is done. So that's pi upon 3 minus pi upon 6. That's to be divided by 3. Let's now put x equals 0 in. So we get sine of 3 times 0 is 0 minus pi upon 6. 0 minus pi upon 6. And that's divided by 3. So there's a calculation here to be done. Here's 2 lots of pi upon 6, double top and bottom. 2 lots of pi upon 6 minus 1 lot of pi upon 6 will just be 1 lot of pi upon 6. Minus the sine of minus pi upon 6. So, essential to working this out is what is the value of sine pi upon 6. And the way to remember this is to take an equilateral triangle of side 2, chop it in half, so this bottom side will be length 1. Pythagoras tells us, Pythagoras' theorem tells us this third side of the right angle triangle will be root 3. And normal angles in an equilateral triangle are 60 degrees, that's pi upon 3. We're interested in half of that, which is pi upon 6. So the sine of pi upon 6 is opposite over hypotenuse. That's 1/2. So this one is 1/2 divided by 3 minus, now what's the sine of pi upon 6 but in the fourth quadrant with a negative angle there? Well, the sine's only positive in the first and second quadrant. An angle of negative pi upon 6 is in the fourth quadrant, and the sine's negative in there. So the sine of negative pi upon 6 will be negative 1/2. And that's over 3. So let's double top and bottom. 1 over 6 minus a negative, it's a positive. Again, double top and bottom. 1 over 6. So that's 2/6, which is 1/3. So the value of that integral, 1/3. That's Mr. Corsi signing out. Hope you enjoyed the video.